Assalamu alaikum wa rahmatullahi wa barakatuh. So, in this lecture, we will learn how to place air terminal. Okay, after doing heat load calculation, then checking the CFM of that particular spaces, then next is how to place the air terminal. So I request you all that you have not watched my previous lecture, then go and watch firstly. Okay, this is the continuation of my lecture. Okay, so this is short video. Let me show you without wasting time. Okay, see, here I am showing in Revit. Okay, AutoCAD is also here, but no issue. Okay, I have to select mechanical template because I have to place the air terminal, right? Or any particular template you can select, no issue, but you have to set the all the things from scratch. So better to select the particular template. Okay, so see, this is the one. I'm not showing you or telling you describe about the Revit. I am showing how to place the air terminal. Okay, I will start another tutorial about only Revit and Navis work. Okay, so see, let me show you firstly. This is the floor 0. Okay, suppose this is a small architecture layout. Okay, this is the one. Here, let me go to ceiling plan. This is the ceiling plan. Okay, and if we check in 3D, so this is in 3D, right? This is in 3D. This is the small architecture layout. I have to place air terminal for this area. Okay, see, for this area total CFM after heat load calculation. Okay, suppose 217 liter per second, right? And for this particular spaces, so I have to place the air terminal here, ceiling diffuser. Okay, I already described about the air terminal, that which air terminal is better and which step we have to follow while selecting the air terminal. Okay, so this is the ceiling grid. Okay, 600 by 600. So which air terminal will be better for this area? Yes, of course, a square diffuser, right? So see, suppose here the dimension of this spaces is here, width and length is this. Okay, I have to place air terminal here. So see, first come and select the air terminal. Okay, so the air terminal is not visible. Why? Because the elevation is 0 0 here. Okay, no issue. Come here and rotation and export elevation. See, 2400 is the elevation of the ceiling, this ceiling. Okay, so now come again air terminal and level 0, elevation is 2400. Now here place, anywhere you can place, no issue. Okay, here So but see, I place the air terminal, but I don't have idea about that how much air terminal I have to place as per the CFM. Okay, this is 217 liter per second. Okay, so either we can place one terminal of this 270 liter per second CFM. Okay, or either 2 3, I don't have idea. Okay, so how I will decide that how much air terminal I have to place? Yes, of course, there is something rule. Okay, so see, I place suppose one air terminal supply and one return, but for this one ceiling diffuser, let me size first. Okay, here this is one software for selecting the air terminal. Okay, also we can select the air terminal from the catalog, but I have this one, so I show you. See, this is supply air diffuser supply. I have to size supply SI. Okay, a square. Now next come here, the noise criteria I already show you in my air terminal lecture, that so this is office, so a noise criteria I consider suppose 30 or 35. Okay, 30 I select. The liter per second is 270 for this particular spaces, I already mentioned here. And this neck velocity VN, it means neck velocity maximum. So neck velocity maximum is, I already show you in my previous lecture. Okay, so better to go and watch that lecture. Okay, here neck velocity I consider 500. It's generally 500 to 700. Okay, but for ceiling diffuser we consider 500, and remain like a register or slot linear diffuser we consider 600 or 700. Okay, this is air terminal velocity for comfort, like a throw velocity. Okay, so for comfort is generally 50 fpm feet per minute, okay, or 100, but we consider generally 50 is good, or 0.5 meter per second. Okay, now find nearest match. So the size of air terminal is 300 into 300. Okay, and 300 is 300. Okay, but here see, the throw is 5.9. this is very important while selecting the air terminal. I already explained in my lecture. Okay, so see, 5.9 is maximum. While supply the air will go maximum how much? 5.9 meter. Okay, and for shorter side, see, the for shorter side we have to multiply this 5.9 with 0.7 or 0.75, right, to get the shorter side about the throw. Okay, but 5.9 is not actual 5.9 because of the some isothermal condition. Okay, so for thermal condition, we generally know that while supply the air will be cool. Okay, and the room air will be slightly hotter than compared to cool, right? So hotter air density, right, will be maximum compared to colder air will be, colder density will be higher. Okay, compared to hotter air. Okay, so volume will be expand. So when supply air will enter in the room, it will get effect, and this 5.9 meter actually it will not travel. So we can take 0.7 like as a safety factor also. Okay, so let me explain, let me show you. what I mean. Here throw is 5.9, right? So 5.9 we multiply 0.7 as a safety factor, 70%. So 4.9, actually we consider 4.1 for this throw, okay, not 5.9, we consider 4.1 throw for the maximum side, okay. And for a smaller side also we do the multiply 0.7 also, okay. So see, the 5.9 multiply, this is the maximum side, right? 4.1. So here come what I mean. 4.13 meter, right? So 4.13 meter, this is one, okay. And for shorter side, we multiply also 0.7, this is shorter side, okay. This is shorter side, but also for shorter side we have to multiply 0.7. This one 0.7 I multiply already, but also we consider the safety factor because of the isothermal effect, okay. So what is actual shorter side? 2.0, okay. We take also 2.0. 2 meter, right? This is the one, see, this is shorter one, this is longer one, this is shorter one, okay. 2 meter. So see, one diffuser is almost okay for this one, see, because see this area represent the flow of the air, okay. It should not hit this wall, nearby wall, see, it is not hitting here, also not hitting here, not hitting here, not hitting, so it is okay, right? And the maximum air will travel up to here, okay. Velocity will be less, but it will travel all this area, okay. But so it is fine, we can place one terminal here, okay. And also we can place one return here, okay. So it is okay, but this area we are not getting the maximum air flow, okay. And also it is not look like good, but it is okay, we can place and it is absolutely okay, okay. So but also we have to consider some, as per the architecture layout, it must be look some premium look, right? So this is step 1, how we place the air terminal as per the throw, okay. So I hope you understand. If you have not understand, then comment below and I will explain again, okay. Now the next, you can say method 2, how to place, okay. Generally we also prefer the method 2, okay. The method 2 is, the formula is x is equal to length divided by 2 into number of air terminal, okay. This is the formula, length by divided by 2 into number of air terminal, okay. So see what it means. It means that this is the length, room length, and this is the width. Okay, so as per this formula, x is equal to length, what is 6365 divide 2 into, I want to place 2 air terminal here. Okay, so 2, how much it will be? 6365 divide 4, 1591, 1591.25. we can ignore 25. Okay, this is x distance. Also similarly we can make x2 what 4901 divide 4. Okay, because this side also we have to place 2 air terminal. Okay, (4901) divide 4, 1225. Okay, 1225. This is x distance, x1, this one. Okay, now what this means? It means, see, here suppose I place one terminal here and the second one I place here. Okay, the third one, the return one, okay, here and here. I am not placing 4 air terminal, I have to place 2 air terminal for supply and 2 for return. Okay, I will change later, or let me check if return is here, supply, return. Okay, we can change here this one also, we can change this one, supply, return, return, supply. Okay, we can also change, no issue. Okay, so I place the air terminal like this. Now come to this x value. See, here x, here, here, we can check like this, and similarly this one, this one, this one. Okay, okay, so see, this value is x. Okay, this is 2x value and this is x value. So here how much this x value is? 1591. Okay, 1591. Now again, if I will change this one 2x value, then this air terminal will again move either and either, right? Either is this side or this side, so this value will be effect. So don't touch this one value, now touch this air terminal, and from wall to this air terminal the distance is x, so 1591, right? 1591. See, 1591, and this is 2x value 3183, automatically it will come, right? See, 1591 multiply 2, 3182, this value is 2x. So this method is called, you can say, x 2x method, x and 2x method. Okay, similarly you can change this value also, right? Other side is 1225, and this one 1225. So this is 2x value. Okay, now you can align, okay, with this grid and from this one. Okay, so see, align AL from this value, right? And you know this one you can align easily. Okay, you can align. So this is the second method to place the air terminal. Okay, now you will say that this air terminal is not perfectly aligned with the ceiling. Yes, of course, but this is the method to place the air terminal as per the method. Okay, now you have to must align this air terminal with this ceiling. Okay, because this ceiling will replace with this air terminal, so you can align. Okay, as per the architecture. So you can align or do what? Okay, so you can align this air terminal with this ceiling, right? So no issue, you can align like this. Okay, and it is perfectly aligned with the ceiling. Remaining you can align like this. Okay, from this one to this one, this one to this one. Okay, so I hope you understand how to align this air terminal. This is the method to place the air terminal. Okay, and if you have some doubt, then comment below and I will explain. Okay, so if you have learned something from this video, then of course like, subscribe. Okay, thank you. Assalamu alaikum warahmatullahi wabarakatuh.